Okay, so we're live on YouTube now. Welcome everyone. Just so you know, this event is being recorded and also live streamed on the ArchAgenda YouTube channel. My name is Daniela Gerdovich, and I am the curator of the ArchAgenda Debates series at the Chicago Architecture Biennial. ArchAgenda is a program partner of the Chicago Architecture Biennial, and this year ArchAgenda Debates theme is focused on cyber-urban incubators in the blockchain metaverse. Today, it is my great pleasure and honor to have ALICIA NAHMAD VAZQUEZ and SHAJAY BHOOSHAN with us. Their presentation is titled Realizing Cyber-Physical Communities and Architectural Technology Stack. Also fantastic to have with us panelists Yele Farinka, Jason Cameron, and later on, Josh Tarrant is going to be joining us. Today's event continues a series of free online events that will occur every Saturday from now until December 4th, starting at 11 a.m. Central Time. So the following are exciting lineup of events that are coming up. On November 13th, we have SOM presenting a Pachacucha style set of presentations and panel discussion. On November 20th, we have Theodore Spyropoulos giving a keynote. And on November 27th, we have Jimenez Lai and Stephen M. Johnson. Also, Design Morphine is going to be presenting on December 4th, and they're going to be talking about their business, but also about their online master's program in advanced computation. So please visit the Chicago Architecture Biennial event calendar for registration details about the ArchAgenda Debates series of free online events. In the weeks preceding, we kicked off the series of events with a two-day symposium titled ArchAgenda Debates, Cyber-Urban Incubators in the Blockchain Metaverse. And last week, we had a keynote lecture by Patrick Schumacher titled Design Drivers in the Metaverse. And you can, you can find these complete videos on the ArchAgenda YouTube channel. So the ArchAgenda Debates aim to spark lively and candid exchange on 21st century societal paradigm shifts, fueled by globally distributed cloud communities, emerging economies, new governance models, novel design agendas, and innovative technologies that transform social synergies, entrepreneurial opportunities, and the process of building cities. The fluidity, mobility, and dynamism of 21st century network society is transforming the way that we design cities. Current societal paradigm shifts are marked by an intensification of systems of communication, complexity, coevolution, responsiveness, and freedom. Urban design innovation is accelerated by the convergence of natural and artificial intelligence, the emergence of distributed peer-to-peer computational networks such as blockchain, advancements in telecommunications, the explosion in real-time decision systems using big data and AI, and the movement towards knowledge economies anchored by research and development. In this context, the world is a laboratory, and entrepreneurship in the open market is the best avenue for creating wealth and improving the quality of life for the greatest number of people. Broadly, this series of events aims to create a gradient of presentations ranging from virtual reality to mixed reality to fully functional cyber-physical communities. With this framework in mind, this particular event was authored by ALICIA and SHAJAY, who taught jointly for several years at AADRL, where they developed their design and theory agendas with all the trajectories that you can read in the brief that they wrote that is published on the event's website. SHAJAY and ALICIA begin their brief with a quoted question from Patrick Schumacher that says, could there be a digitally empowered, prosperity-enhancing humanist urbanism? Could such an urbanism be achieved without prescription? And without further ado, I'm going to tell you a little bit about SHAJAY's background, and then I'm going to introduce him and he's going to speak. So SHAJAY BHOOSHAN is a senior associate at Zaha Hadid Architects, where he co-founded and heads the Computation and Design research group, ZHACODE. He is an alumnus and studio master at the postgraduate course of Design Research Laboratory at the Architectural Association, known as AADRL. There he explores participatory systems of development of the built environment as enabled by advanced digital technologies of design and manufacturing. SHAJAY pursues his interest in manufacturing and structurally informed design technologies as a PhD candidate at the Block Research Group, known as BRG, at ETH Zurich, and previously as MPhil graduate of the University of Bath in the UK. SHAJAY has published in scientific journals and conferences, along with contributions to architectural discourse through Architectural Design and other magazines. He routinely engages in public speaking at various professional and academic conferences, events, and institutions across the world. Please help me welcome SHAJAY.
Thank you, Daniela. I'm gonna share my screen. I guess that's visible by now, right?
Yes, it is.
Yeah. Yes, again, thanks a lot, Daniela, for organizing the larger events of ArchAgenda Debates, and also like this opportunity to organize this panel with Yele and Jason and Josh subsequently a little bit later. And like we are particularly excited by this phase of our work, like ALICIA and I, that we started at the Design Research Lab, and some of it has manifested it as opportunities to realize some of this in both in professional life and continue some of this in more scientific research trajectories. So I'm gonna just set the table a little bit on the more digital side of things, and then ALICIA is gonna talk more about the physical side, and then Yele and Jason and ourselves can engage in a kind of informal but like kind of insightful conversation. So so the presentation and also the panels are kind of operate in the foreground of like this topic of how to form communities, both online or first online and then subsequently offline. And this let's say paradigm or movement is picking up steam, as we discovered like last in the previous debates on a couple of Saturdays ago. And also if you even a cursory look online will reveal that like there's a lot of energy around this topic, be it charter cities, be it free economic zones, be it mixed utility districts, be it urban rezoning, etc. So there's definitely full various scales of operation and engagement with this idea. And one thing that comes across in all of these is that the technology to do this is already here. So, and it requires just stacking them together to enable both online community formation and then subsequently hosting them physically through creation of appropriate architecture and urbanism. So in that context, I'm going to try and convince you that like these topics, seemingly unrelated topics of computer graphics and geometry and robotics and robotic manufacturing and video game technologies could actually be a part of like the solution to this. And what do I mean by this? It's the kind of lack of agency in 21st century architecture and urbanism. So the built environment really affects us all, but hardly any one of us has any agency in directing what gets built, when it gets built, how it gets built, etc. So as a consequence, much of the built environment is unloved and is routinely demolished. And this causes even more pollution from already wastefully produced buildings. And so what is the solution to that is the topic of this presentation. So 20th century obsession of thinking of buildings as cars and cities as machines, and a kind of sharp focus on automation and universality has kind of really incentivized and promoted like the kind of sprawl cities that we see across the world. A city that is tailored for the motor car, and not only that, like it has also led to dense, human-friendly, pedestrian-friendly urbanism to fall out of favor. People actually question this kind of urbanism even to this day. But reality actually bears the opposite evidence. Sprawl consumes more resources, more heating, more commute, more per capita infrastructure. As you can see, Atlanta and Barcelona, just as an example, have the same population, but an order of more magnitude in carbon footprint. And so it's perhaps time to kind of think of, to refocus, realign, and our priorities on a material and energy conserving architecture and urbanism, and that focuses on adaptability rather than automation and universality. So in order to do this, like we believe that one of two things need to change, at least two things need to change. One of them is how we design and how we build. And this is where we believe topics of geometry and robots or digital design of a very specific kind and digital manufacturing of a very specific kind can play a significant role. One of the material conserving wisdoms from the ancient world is, and material conserving and energy conserving ideas and paradigms from the previous centuries is to use curved shapes like arches and walls and domes to save on material and also the amount of energy needed to construct these things. And these ideas we are finding are very compatible with modern day robotic manufacturing, particularly 3D printing. So you could pretty much consider 3D printing, particularly in materials like concrete and clay, as like a kind of scaled down version of masonry, unreinforced masonry. And we have taken this idea recently and like demonstrated it at scale. Like this is a completely fully unreinforced concrete 3D printed masonry bridge where there is no glue between any of these blocks. There are 53 blocks, and there's hardly any steel except for like the steel at the feet and the cable that ties all of them together, all of the feet together. And not only that, like we can use, there's no steel or reinforcement in the concrete either. So it can be completely disassembled and reassembled. It's all dry jointed, and also significantly hollow. So all of these blocks are actually hollow, as enabled by the precision placement of material by robotic 3D printing. So as a consequence, these aspects kind of, I'm not going to go into the details, but these aspects of unreinforced masonry and 3D printing coming together, so our geometry and robots coming together, really help us reduce the total amount of construction material and amount of energy needed to produce the shapes. And it also enables reuse of material because it's all dry assembled. It can be dismantled and crushed, or dismantled and reassembled elsewhere. And it also therefore allows for recycling for two reasons. A, it is dry assembled, so it can be crushed, and concrete can be crushed easily, and the other is because the steel and concrete are clearly separated. Usually in concrete, like the steel is intertwined with the concrete, making recycling very, very difficult. So these already give us a hint as to how like ancient wisdoms and modern technologies can really help reduce, reuse, and recycle and meet the sustainable development goals. And like Block Research Group, where I'm doing my PhD, they're commercializing some of these tech ideas and principles and embedding them in commercialized floor slabs, which can be customized per building or per floor of a building. And as a consequence, they're able to save 70% on concrete and 90% on steel. And if you imagine that more than 40% of a building's weight and material usage is in the floor slab. And so we can assume like if 70% of that and 90% of the steel of that is reduced, we can do the math as how this is going to have a substantial impact on the buildings of the world. Second change we believe that is necessary is who decides what gets built, where it gets built, and when, and how big, etc. Because currently these are controlled by a handful of people sitting in planning commissions, and the vast majority of people have no real say in this. And so we believe here the technology of video games can really help alleviate some of these aspects of lack of agency of the large majority of people and the built environment. And you would be surprised to know that like a large amount of computer-aided planning software or design software do not represent users. They only represent the buildings and the walls and the infrastructure. And like that's where games are particularly interesting, because games are built around users and built around user experience. And so we have been for the last 6 to 7 years in our research, like really focused on doing architecture through video games, video game technology. And the other thing is that video games also represent user choices, which is something that like most CAD software doesn't. And that's these two aspects like really are the reasons why we gravitated towards the use of combining the use of our digital design technologies with user-oriented game technologies. And so we'll talk a bit more about this like later. But the other aspect when we combine these two things is that we can literally test thousands of options virtually and in relation to the users. Like, so it doesn't need to be automatedly tested. It can be tested in relation to users' choices and by actual preferences of users. And so this is one of the ideas that we are trying to materialize in the real world, like build a little piece of software for a project that Alicia and I are kind of contributing from our respective institutions as Zaha Hadid Architects and her company for a project in Honduras that like I will present a bit more detail later. So these three things, like material and energy conserving and robotically made building parts, combined with end user participation, we believe can really provide the solution to the kind of lack of or the monotony of the built environment. And so we can customize buildings to not only the social demographics, like the various user groups, and also like to the cultural context, could be urban context like this, or if like either the users change or the context change, in this case, like it would be a completely different user demographic, and like it can result in a completely different architecture. So in that sense, one style need not fit all, and one size need not fit all. And so these customization technologies really help make the built environment to become more loved than it is currently, and therefore hopefully more sustainable in the sense that it doesn't fall into disuse and have to be demolished. And so this then leads us to the next question. What are the models of like organizing these tech stacks? And we at least see two models that are currently being tested out. One is a very centralized, centrally owned and operated stack, like companies like Google and Katera and so on. And the other is what we are proposing, using this kind of decentralized participatory mechanism. And so what is a centralized model? It has a lot of efficiencies in terms of command and control, vertical integration, and saving of resource, etc. But like Google kind of tried this in Toronto in their famous Toronto Keys project through Sidewalk Lab. Like the goals are very similar, like to reduce cost of living, efficient transportation, energy usage, etc. And they also did like the key components, like which is digital design for manufacturing and assembly, i.e. have a library of parts and assemble buildings as a Lego of from a Lego of those parts, and subsequently also know what is the supply chain of material that can help make those kit of parts, and also the factory that will make those parts. So in other words, like they have really looked at the top half, which is the digital design for manufacturing assembly, which we are calling A, let's say, and B as well, digital manufacturing, which is like having a good idea of the supply chain and how the parts can be produced efficiently. All of these ideas are kind of borrowed from the automobile industry or the aeronautics industry in the way the cars are made, or and they also try to engage with a very engage with the public through questionnaires and surveys, etc. This process had like 20,000 interviews, and it spanned over 12 or 13 months. It just was very labor intensive and time intensive. And as a consequence, there were some issues. Obviously, like as we now know, like Toronto Keys project was shelved, and Google exited, and they're now trying to use similar ideas or revised ideas elsewhere. And what were some of the issues that we can notice? We can learn from another industry, for example, that of video games. And one of those is one of the examples is of like Fortnite, like where there is a centralized owner, there's a singular owner, a singular developer of the game, and it's a closed one-sided market where players only make expenses, like they buy assets, and so it's usually just spending a lot of time without creating much value outside of like the pleasure and skill development. And in contrast, we can take a look at the rise of like so-called crypto games, where the assets are actually owned by the players, and then they subsequently pool them together, so they're communally owned asset pools. And this small change really makes this game to be a fully functional cyber economy. And that then means that like people can actually, they don't need to waste their time. Like, so not only are they earning skills, but they're also able to sustain, can also earn an income, and then there can be a full-on cyber economy. And it's a two-sided or multi-sided economy as opposed to a single closed one-sided market. So some other issues, the more important issues with this centralized model is that it kind of really doesn't account for game theoretic responses of people. Like it really doesn't account for people, like in the sense that when large number of stakeholders come together, like they are driven by incentive, and the centralized model, particularly as it is configured now, like usually doesn't account for kind of behavior of people, and like kind of particularly incentive maximization, because the economy is usually modeled in the ideas of flows and never as a kind of agent-based modeling. And so this then kind of leads to the idea that like human systems are kind of really hard to hack, like, and like, which means we have to consider like some of the incentive structures like that drive decision making. And these challenges are referring to the medical and education industry, but like we can easily replace that with architecture, engineering, and construction industry, and all of these challenges will readily apply. One is inertia around status quo. Because there is a lot of investment into creating like the current supply chains and creating the current planning regimes, etc. And subsequently that leads to a lot of inertia. And second, like there's a disconnect between users, the stakeholders, and the buyers, etc. And also the other challenge is that the very slow sales cycle, making innovation very, very hard. And then also there's a lot of legacy infrastructure that needs to be replaced, and that causes a lot of investment to do that. So all of these challenges readily apply to the architecture industry. And we believe like using games and using robotic manufacturing technologies, which are agile microfactories, etc., which Alicia will talk about, combined with like new digital design technologies that actually build upon ancient wisdoms can actually address these challenges. But we can see why Google tried to do the opposite route, like, because if you have a centralized model, you only need to disrupt this 1% of companies that are actually in charge of more than 40% of the annual revenue of the construction industry. And these are statistics from the UK. So if you have a centralized model, you have a better chance of disrupting this 1%, and that already leads to a significant amount of revenue. But reality is that 99% of the construction industry is actually small, medium businesses. But they also make significant contributions to the annual turnover in the UK, and presumably this is very similar elsewhere in the world. And so that's where we are trying to think of, like, can there be another model for the other 99%, so to speak? And in here is where we believe, like, participatory models can really shine through. And we are not advocating for a direct opposition, like it's like a hybrid between centralized efficiencies but also decentralized ownership of assets and value. And one example that I will go through or end with is this project that we are currently working on to try and realize between Zaha Hadid Architects and Honduras Prospera, where ALICIA is engaged from the client side. And so we started with like two hypothetical companies called Confico and Circular Factory, and Circular Factory is now being realized. What do these two companies are in charge of, like kind of in the kind of intellectual, let's say, thought experiment in creating this particular outcome, like which is a small residential community, a pilot project that where we want to demonstrate that these ideas can actually come together. So one thing that we borrowed or changed from the Google model is to have adaptability and like get rid of universality and adapt like our design and architecture and the configurations to the terrain and to the climate and to the people. And so, which is typically not done in modular construction, where you're building it in a gigafactory and like kind of placing it on site. So that's one. But like we also improve the amount of user choice. Like so these are just the various a small fraction of the users possible choices that people, when users choose their site, let's say on the top row, we will compute like the corresponding kind of architectural outcome that can fit within those chosen blocks. But we also retain, like we develop like the combinatorial possibilities, which is significantly more than like a simple Lego piece, where it is still allows for user customization. And like, so it's not just somebody's house, but it can also become part of their lifestyle. So it becomes their home. So we are trying to improve the combinatorial variety and customizability while still retaining the kit of parts and the kind of efficiencies of a small set of parts that can be manufactured. And all of these will also be account for how it will be manufactured using robots that are imported, and not like the entire building that is imported. Like, so we import robots and we use local material, which Alicia will talk a bit more about this particular aspect of microfactories. And this then like really helps us understand like in depth, like how to convert like a material at source into the finished product, and like kind of really have a good idea of like not only the machine time, but human resource and that is needed to these operations. So we are designing for these new constraints. So we are not taking an existing design and like kind of trying to make it using microfactories. We are actually designing the buildings in relation to the constraints and opportunities offered by the microfactory and the local supply chain. So this is a little video that like we made, or the so-called configurator software, which is built on Unreal game engine, which allows for people to not only customize their house, but they can also choose where they want to locate their house in relation to others. So it's not only the interiors, but also the exterior location and in relation to the views that may be on offer, or in relation to the neighbors that they would like to be with, etc. So what did this allow us? The configurator, in a way, allows us to make transparent all the decisions. First of all, it gamifies and provides intuitive decision support for presumably large investments for most people. And so in that sense, it de-risks the buying process for buyers. And it also, interestingly, provides insights for us as architects. So these are some of the choices that the users made with regard to their where they wanted their house. And you can notice everybody wanted bookends and nobody wanted to place their house in the middle, because obviously you want views. And so now then, and they also wanted to be as high up the hill as possible. So what we did then, so on the left was the configuration as we suggested, and a accumulation of all their choices, of the user choices, and we decompose them and recompose them into a different configuration, so that like a large number of their user preferences are accounted for. And so so the original configuration was on the top, and it had about 66% of bookend units and views, or 66% of the units had views. And like later, when we reconfigured them based on user preferences, now we have a lot more open views, for example. So this is just one way where we could account for the preferences. And so this kind of really de-risks the development for the buyers, for sure. And how does it de-risk the development for the developer? The developer basically only needs to build what already users know that they want, so they don't have to build it first and then try and sell it, and then run the risk of building something that nobody wants. So we are able to capture a lot of the preferences through this. And we also now know that of all the choices on offer, some of them are better preferred. And not only that, we also know as architects and suppliers how there's a firm brief of what should be designed and what are the conflicts that need to be resolved. So it's a kind of discovery machine, so we don't have to build in real life and then discover. We can kind of do this virtually. And so we also know what to engineer, etc. And so we are going through now the process of finally refining some of the more expert decisions, like structure, material, and all of these aspects which users don't really care about. So we are kind of putting the horse or the cart before the horse, and that's proving to be quite useful to de-risk the project to everybody. And so this is the current state, and we're about to start construction in a few weeks from now. And initially we're going to start with a pilot of 10 or 11 houses, and hopefully if it is successful, we can then truly deploy both these companies for in the region, to kickstart housing communities, or kickstart local mixed use communities, etc. So just in summary, what we set out to do was contrast our effort with Google, where the design IP is universal, automatable, software is very standardized, and the factory that makes it is a very large gigafactory, and community engagement is very laborious and time intensive. And we, on the other hand, are using very localized and adapted designs, which are new aesthetics, but also material and construction wise efficient. And instead of large gigafactories, we're trying to develop the designs suited to microfactories. And also, instead of like laborious surveys and questionnaires, we are kind of using a gamified approach. And these two approaches don't need to be contrasting. Sorry, they don't need to be competing. They can actually coexist, hopefully, in various stages of development. But in any case, like, we believe either side has to focus on user participation and to be as direct to consumer as possible. And this, we hope, like, kind of can realize one of the early manifestos of like Ray and Charles Eames, which they set out in the 1960s, where they talk a lot about these ideas of a vocabulary, a fresh vocabulary of materials and techniques, understanding of family behavior, understanding of economics, and understanding of mass production. And these resulted in only a handful of so-called case study houses, but we hope, like, with new technologies, can really deliver a solution at scale. So thank you very much for your attention, and I look forward to the panel discussion.
Thank you so much, SHAJAY. That was wonderful. And yeah, and it's good to see an expansion of things that we've kind of chatted about over the last year. So next I'm going to introduce ALICIA NAHMAD VAZQUEZ. And ALICIA is the founder of Architecture Extrapolated and works as assistant professor of robotics and AI in architecture at the University of Calgary. She's also the co-director of the Laboratory for Integrative Design. For the last 5 years, ALICIA worked as studio master, co-leading the NAHMAD VAZQUEZ studio at the Architectural Association Design Research Lab, AADRL, in the master's program. As a research-based practicing architect, ALICIA explores materials and digital design and fabrication technologies, along with digitization of building trades and the wisdom of traditional building cultures. Her projects include the construction of award-winning knit candela and diverse collaborations with practice and academic institutions on the development and on-site construction shell structures. She holds a PhD in Human-Robot Collaborative HRC Design from Cardiff University and an MArch from AADRL. ALICIA previously worked developing design tools for practices like Populous and Zaha Hadid Architects. ALICIA has also been an artist in residence at Autodesk Pier 9 and has taught and lectured extensively in Latin America and Europe. Her research has been widely published internationally in journals and conference proceedings. So welcome, ALICIA.
Let me start my video. Thank you very much, Daniela. Let me just share my screen. Oh. Is that good now?
Yes, we see your screen.
Oh, perfect. Yeah, so thank you very much for like the invitation and to this event. I think it has been like a great series of events, and I'm very glad to be part of them. And like today, it's going to be a continuation of some of the work that SHAJAY presented and introduced to us, and also what is like our interest on like what these are realizing these cyber-physical communities, in the sense of like what will be their physical realization, or how can we like integrate a lot of these parameters, exploratory parameters and fabrication parameters, with an idea that that they can be part of the combinatorial and of the games and of the participatory setup for the different players that are involved in like all of these new technologies. So something in interest for us is that we are kind of going through an era of like technological optimism, and really it's fascinating. I think that a lot of the things that we are kind of seeing now, participatory communities like the metaverse, all of these new things, but in a way, we like a lot of technological advances are being done, even like on going to the moon again, like on the 60s and 70s. But a lot of the dreams in the built environment are not really being corresponding or responding to that, the built environment seems to still be in a very kind of old-fashioned way of proceeding, of building, and of realizing materiality. So the main question is like, how can we democratize this construction and like through like technological optimism and effective resource utilization? So how can digital construction be democratic, and how can design be participatory, and also how can digital design kind of help us to optimize resource utilization effectively, functionally, and beautifully? We know that also there are many challenges to be addressed right now in terms of the built environment, on sustainability, and being effective in how we build for the future. So that has been that was our long interest at the DRL. We explored that during the time the last 5 years, really kind of work into like exploring the tectonics and new tectonics that respond to the new tools, to the advanced machines. Like we know that robotics in architecture now have been around for like over 15 years, and how can we respond to these, like when we are designing like housing, for example, we did a lot of explorations into domestic architecture, into housing, and what is the responses when we can integrate a lot of the new tectonics that we are able to do now, and that also like a lot of what SHAJAY was explaining can allow us to have a more efficient use of resources. Additionally, and I will kind of just go quickly through this video that you have already seen, but it's in kind of adding this idea of the human, the occupant or the user be part of the decision making, be also an active player. But one of our ideas here is like every decision that the user is making should also be based on how this will be fabricated, how will this actually be ultimately made, without kind of defaulting into a situation where potentially the end result is actually nothing that we could build. And if we integrate all of the kind of novel technologies, we could actually kind of create a new vocabulary that correspond to all of these decisions and dynamism that are going on. And also, oops, sorry. Yeah, how the customization goes from like these communities, like kind of online communities, when they kind of start to also become physical. So that realization of preferences that we can start to transfer from like your digital preferences into your physical preferences, can these like digital communities be actually manifested and also have a physical vocabulary to them as they are expressed, which are like kind of very kind of interesting questions for us. How can these communities will actually be feeling when they actually become physical and when they start living together and working together in both the cyber and the digital and the physical environment. So how these two kind of communicate and talk to each other in terms of preferences, of user preferences. And with the idea of having all of the fabrication principles embedded into the decision making and into all of the different options and vocabulary that we are offering through the participatory platform that we were developing. So these are kind of a lot of the work and the research that we were doing over the last 5 years, and we kind of continue to do now in like different ways in trying to actually get to the physical manifestation and the physical realization of a lot of these spaces, following the design, the participatory design to fabrication sequences that we are started to like establish and delineate in these kind of early stages, iterations of the idea. And these are like also like ideas of like how can these tools be used in the cases where like we are talking about specific sites, like locations that could be not addressed through like traditional modes of building, traditional modes of construction. So also when we start to think about these, like for example, like these are like small sites in London, or like far away or remote locations, or spaces or places in which like current practices of prefabrication or like of construction will not be viable, will not be accessible, will kind of result in a lot of like either like transport costs, closures, infrastructure problems. So how can we transfer these tools to be part of the environment as they are built? And this came like from a lot of our previous experience into like in building, in physical realization of the forms, and also a lot of the robotic explorations in like different digital fabrication techniques that we have been exploring since AADRL and before, like for the last 12 years, in like including like kind of hot wire cutting, wood processing, 3D printing, like really kind of trying to see like the full range and vocabulary that we can use to with the same machine, to the same robotic arm, like all of the different possibilities that it can offer us. And that kind of started to delineate the proposition of moving from like what we call like design for what is known as like design for manufacturing and assembly, DFMA, that started to exist like in the 1980s and came as a response to like the situation that on-site construction maybe is not very controlled. We cannot have a lot of rigor. A lot of the parameters are very variable depending on the location, on the situation of the individuals. So it kind of came as a production line, right? Where we have like these very large machines that are very optimized to produce components. They work in a factory setup where like panels are fabricated and they kind of are transported on site. The design at the time had also had to be adjusted in order to respond to this new fabrication constraint or like of like the production line. So designs were adjusted. Now we see that this is still the current status. We kind of came to a position into where like large amount of production like is in control of like a very small percentage of the actually contractors that can afford these large format machines, that can afford the large investment on skills, on digital building, on spaces that this kind of fabrication requires. Additionally, there is like a lot of transportation costs. There are a lot of additional costs to the finished product that are not, a lot of the times are not factored into the initial contribution. And also, like like as I mentioned, like the amount of space that these machines can take. So that has started to be our kind of driving thing of like, how can we make these machines? How can we democratize these processes? And something very interesting through our research was like the on-site construction, on-site skills, which are kind of being replaced by manufacturing skills. And when we are kind of facing a situation of like people that are from the manufacturing industry, that are from the construction industry, doing our buildings, and also so there is a loss of skills, but also there is a lack of like enough young people interested on joining the construction industry. So that's also kind of reducing, resulting in like a terrible like loss of skills, where like 25% of the workers are like under 20 years. So there's no one really to take over the skills of people that are retiring, that are at the end of their working life. And additionally, we are also looking at the idea of like, when we have like on-site construction, there is a benefit to the local economy, to everyone around it, that brings prosperity to the areas where construction is being realized, as opposed to just being on a factory. And also a lot of the loss of intricacy, the loss of detail that we can see from like kind of maybe previous works that has really kind of resulted in a more like a standardization. So design has become a lot more customized, a lot more intricate, but that hasn't been equivalent, hasn't been realized on fabrication, although all the technology that we have and all of the new machines that we are using, and all the technological excitement that we are going through. And that from there it came the proposition of design for what we are calling design for robo-factoring, which basically is kind of flipping the model and saying, well, like how can we use this machine that is that is cheap, is very economically accessible, that also is very flexible, but somehow has been constrained to be doing repetitive tasks and on the setup of a factory, right? That is what we traditionally think about these guys, and that and we know that depending on what kind of tool, what kind of end effector we kind of position on them, we have explored like a lot of different possibilities. So this is like a 3D printing, also like a lot of work that we have been doing on the realm of like hot wire cutting, and the concept of that we are that we are kind of working towards is having like this single flexible machine that could actually use a lot of different tools and can produce the final, the pieces. So with accuracy, with control, which were some of the main drivers into moving from on-site construction into off-site construction, was the lack of this kind of rigor and quantitative data that would allow us to understand how things are being made and manufactured. So kind of a lot of the work is focused on like, okay, how can we like get these machines, send them into an island or just use them locally, and actually like keep keep the efficiency and keep like the accuracy, but making it more accessible and making them to be a part of like the on-site construction process. So it's like moving from like a production line with like very specialized machines to like a single cell with like a very flexible machine. We know that there's, and also it's a machine that we know that there are like companies like Otico that already has a robot in a box, and the robot is kind of moving around, and they kind of have proven that this is something that they are kind of still is a single task, but that they are kind of doing, and is something that is very much a very good precedent and reference to what we are looking at. Also, we know that in other industries like the car industry that has been like so traditionally and so established for years, we know that arrival and new startups are also starting to come to say, well, we need to kind of change the production to have a microfactory, like a more flexible production line that could adapt to all the current circumstances and to changes. But that also requires like a change on the design, on how they approach the design. And one of the main things that Arrival kind of talks about is how they had to actually rechange, like a normal car could not be actually made into a microfactory. We need to kind of design for this purpose-made small configuration that is more flexible, but that also has its own constraints. So I'm going to talk about some of the kind of iterations and projects that we have been trying to work to test some of the ideas, like of moving from design for manufacturing and assembly to design for robo-factoring. And with the aim of having like a decentralized and distributed fabrication system for architecture. So this is the main premise, like that now we are in the BIM premise, where like kind of things are everything is done by the architect, then is done on the factory, then sent on site. So the idea is to actually then send all of these to the design for robo-factoring cell, where we can be doing the data collection. We can also be using some of the parameters that have been set up, and we can also be interacting with the local trades and with the local skills. We're looking at multiple integrated robotic processes like that could include like scanning, milling, assembling, eventually 3D printing, and how we can like use this cell-based strategy, taking advantage of the multi-use, flexible, affordable machines that we're proposing. We have done some like iterations on like pick and place, and like kind of some ideas on like 3D printing. And also like the idea of like it could be like of a microarray of like of the cells, where we're also looking at options in which like there are different cells and they can come all together, but then they could be taken away from site as they are not required anymore, or more of them can come. So there is like a communication and a protocol between them, so that it's not always like a single one, but they also like eventually the contractors or the local people, if they are interested, they could eventually just keep one for them once they kind of also get the skills. And we have like we've been working on different projects that require from like different iterations, different processes. So that's something that we have been looking at. And basically our proposition is like relying on a single chip, multiple use machine designed with degrees of freedom, distributed, decentralized, and in a container that can engage with on-site economies and can bring prosperity to the region. And also kind of engage with SMEs, with like the small contractors that currently cannot be digitized and are kind of really kind of setting us back as an industry in a context where like a lot of the industry cannot be digitized just because they don't have even access to the skills or to the machines because they are just too expensive or too complex. So kind of really engaging with like the majority of the construction industry, which is still like kind of SMEs. So I want to like just show two of the projects that we have been working on, trying to like look at these new vocabularies and design that could like and that are adapted from their inception for a design for robo-factoring strategy, and how we can also start to capture a lot of these geometrical constraints, geometrical issues that we need to create a vocabulary that can be that can be used for robo-factoring. Like in this case, like whereas we can like have different conditions, what materials can we use, what kind of end effectors, what kind of tools can we create, and what would be the sequencing between them to be able to produce these buildings. So these are some of like the kind of studies that at the DRL also on like the vocabulary that could then become what adapted to the machines, or is already conceived as part of the on its dimensions and on its variations on what the machines will do. So these are also like a project on facade panels that we work on the same idea. This is a project that we are currently fabricating. It was also conceived as like how can we like it's like a retrofit a building, an old building, without kind of demolishing it and kind of using the most just retrofit the facade and not having to bring the panels, but actually fabricating them on site, just kind of sending the robots. So the design was kind of considering what is like the thermal considerations, like a traditional kind of like thermal consideration sort of design process, but also what is the maximum dimensions that that the two robots on site will be able to do, that people can like be kind of carrying, and the material constraints that we were going to be having. So these were like some of like the resulting kind of facade panels, considering the on-site fabrication on a micro factory. We also did like some analysis into like efficiency, and then these are like some of like like the test on like trying to say, okay, like this is the size of the cell that we are going to be having on site, and we are kind of starting to do some of like the laminations of like the bending and using the machines first for like using the robots that are kind of first bending and the glue lamp that we are kind of testing and producing. And after that, they are also kind of doing all of the mitering and milling for the pieces. So out of this, we built the first full-scale prototype, one-to-one prototype, just with our partners that are giving us like the compression rings. Basically is like a facade that is based on like a network of compression rings used by the that kind of keep it together. Those are like steel compression rings, and it's hanging from the slab, so it is connected to the slabs of the old building. And the processes in this case is like where we have like the bending process followed by the we have the bending process in the robot. We also have the bending process for the secondary members, in which the bending process becomes made by a custom-made machine that we made that could also fit inside the same setup. So it's not only the container, not only with the robots, but also with additional machines that are required in the process. In this case, this was the initial test, so the laminations are not glued. They eventually got glued. On how we can actually achieve the curvatures that we require by just having a simple like kind of linear actuator-based machine that could also be embedded in the same place. So everything is just like inside like a 20-foot container that or on that dimensions. It is not inside the actual active container. And then this is kind of the prototype, the first facade prototype that we have with like the different steel nodes and the laminations and everything done inside the design for robo-factoring strategy. The other project I'm going to talk about is the Honduras project that we are kind of having the opportunity to collaborate with Zaha Hadid Architects, with Code, into how can we realize this project. Is in a remote location on an island, sorry, and we are also considering one of the axes of the project is to bring prosperity to the region, to upskill the locals. So on that sense, we are also working in establishing like this facility there, just like the most amount of processes that we can capture on the robot arms. It's a similar configuration. It's like with the robots on a rail. We are also kind of having a study of all the different parts, so we now an understanding of what are the different parts that kind of they are proposing. And it has been a very interesting kind of iterative process of like feedback of working directly with like the designers into what processes they need and how can we actually use them inside the context of like a micro factory. How can the dimensions, the sizes, even the weight, all of these things can actually work for what we are doing. We have like all of the modules. We are also developing like the software kind of side of this, that is what kind of allows for all the parts, like trying to bring a lot of the control and the rigor that is what is more like preferred from offsite construction, like the idea that we can that you can track how the pieces are made. You can have a bill of materials. You can understand all of the timings that a single piece will require. You can understand all of the processes, which a lot of the time is basically what holds back on-site construction is the lack of all of these quantitative data. So we are also working on that, on like kind of having an interface in which it can be continuously updated as the design iterations kind of keep changing. But we do have access to like all the different pieces that are required to make this building on very near site. And as we kind of look through them, as the design gets updated, we also get ourselves updated, and we also know what will be like the different bill of materials that is going to be required, what are the different fabrication processes that will be required, and we can feed them back with this information which they are asking us. And also from the side of the client, is kind of interesting for him to kind of be able to follow the idea of the microfactory and of how can we actually start this on site. We are aiming to start the production in the first half of next year. But all of this is kind of a lot of the work that we are doing on the background to have to connect the different machines and the different tools, and also the different end effectors that the robots are kind of continually changing and are going to be using. And sorry, and all of these different parts are kind of coming directly from the different iterations that we are getting, and that are by the RBU. So like when the configurator kind of like what Shaya was mentioning, like people like the bookends or like the other kind of units, we know what are the parts for those units, or we can just very quickly also kind of give them this feedback on what they are looking at by the changes that are being on the configurator. We're also looking at all of the different processes that are required. So it's like on the microfactory, and having the human time, the machine times, and the unsupervised times, which kind of more or less respond to like storage or kind of drying processes, and also having an idea of how we can start to refine these, and we can start to also work with the people that are kind of going to be on site. Like they can also have an interaction where they can start to log and to log what they did, what things went wrong, what times. So we can also start to iterate on this and to refine it accordingly as to what is happening on the reality. And we are kind of also trying to control like what are the different optimize like our uses, so we know that everything is kind of being used, that we are able to do it on time. So like so that is kind of some of the work that we are currently doing on this project, on kind of setting up this design for robo-factoring idea, and setting up all of the process and effectors that are required in able to deliver these, which we are looking to start very soon. And these are some of the prototypical pieces or the prototypes, let's say, that we have been working on for this project. Thank you.
Thank you so much. That was great. Thank you. So we're going to move on to the panel discussion, but I actually, so SHAJAY and ALICIA invited 3 panelists, but I asked them to also introduce their work very briefly. And I'm thinking we could start with Yele Faringa. And Yele is an architecture and robotics specialist and CTO of ArchAgenda, responsible for the development and production of tailor-made building products at scale. While developing his PhD thesis at TU Delft, Yele established a full robotics lab in the docks of Rotterdam. Here he developed the technical underpinnings for Odico Formwork Robotics, the first publicly traded architectural robotics company, which he co-founded in 2012. Technologies that Yele developed include hot wire, hot blade, diamond wire cutting, and large-scale 3D printing, and are applied at high-profile construction projects. Yele has taught and lectured internationally at Bartlett Architectural Association, Paris Malekwi, IAAC, ETH Zurich, TU Delft, and Aarhus School of Architecture. Yella is a founding partner at EZCT Architecture and Design Research. The work of the office is widely exhibited. Exhibitions include Mori Art Museum, Tokyo, Archilab, Orleans, Barbican Gallery, Design Miami, Basel, and projects at the office are part of the Pompidou Center Permanent Collection and the Frac Center, Orleans. He's a longtime contributor of Python LCC project, and some of his fascinations include level sets, stereotomy, and power tools. So take it away.
Thanks, Daniela, for the invitation. Thank you, Alicia. Let me just set up my screen sharing. Yeah, here we go. So I'm gonna touch on a number of aspects that have been developing over the years and how this ultimately conjoins in robotic fabrication. So work that we developed in the early days of EZCT Architecture and Design Research was very much focused on exploring the potential of artificial intelligence to conceive architecture, to conceive architecture in such a way that lies beyond what you're capable of imagining yourself, to develop computational mechanisms to sort of pierce through the glass ceiling of your own intellect. So there's a almost alchemical aspect about this work. So in a sense, we were combining both simulation, daylight simulation. It seems sort of insanely obvious to use daylight simulation as an aspect in your to evolve that in your design. The interesting thing about evolutionary computing is that you can do it at such a finesse, at such a unbelievable level of granularity that sort of these obvious design strategies can be revised in a very meaningful manner. At the time, we were also starting to become interested in pursuing these kind of competitions and building them. But at that stage, this is quite a while ago. So while robotics manufacturing has been progressing over the last 10, 15 years ago, this competition was also very much a motivation for us to delve into robotics, since existing building contractors were just not able to deliver such a design, let alone for a reasonable price. So that the feeling is that we're harking back almost, at Renaissance times, where and I think Alicia also mentioned this with the expressions designed for robot factoring. I mean, this is a very ancient idea in a sense, right? Is that with an architect like Brunelleschi, there is no schism between, let's say, the innovations that were developed while building the Duomo in Florence and the conception of the building itself. That was a continuity in a sense, right? Where in our day and age, sort of that schism has been introduced. So I think there's this joint interest in closing the schism. So in the credit crunch, all of
I'm
these
so sorry, Yele. I'm so sorry. Can you just speak up a little bit? It's really hard to hear you.
I'm sorry.
Yeah, that's better.
So.
Thank you.
Yeah. So in the credit crunch, what really helped is that a lot of automotive industry were being reshored, or a lot of factories were closing down. So really, a lot of these large industrial robots became available. While I was developing my PhD thesis, I managed to get a hold of them and ship these to a fantastic workshop in the harbor of Rotterdam, where we started to explore hot wire cutting. Until that, around that moment in 2012, architects were mostly adapting technologies from other industries, for instance, CNC milling, while they don't really scale to architectural proportions, right? So it was really necessary for us to find methods and techniques where we can utilize this newfound resource, but at the scale where we are working with. So one of the first outputs, a project together with the late beloved Matthias Riepman, also from the BRG group, where SHAJAY is working on his thesis. We worked on the design of a dome where the structure is only subjected to compression only forces, right? So also the material that we utilized, EPS foam, can deal with lots and lots of compression forces and very little tensile forces. So I think that's also a strand of research that where we have overlapping interests. So in order to unlock that potential, it's also very important that the toolpath generation is optimal. And I developed a piece of software called PyRapid, which became the underpinning, sort of the foundational technology for Audico formwork robotics. So Alicia spoke quite in depth and showed a lot of work what we did back in the days at Audico. So very proud that this is sort of the first publicly traded architectural robotics company. That's great. So after processing a lot of EPS, a lot of foam, I also became interested in working with more classical materials. So sort of as an architect, there seems something quintessential about working with natural stone. And in a sense, from a geometric perspective, the toolpath planning isn't really all that different, right? It's still subjected to these kind of ruled surfaces where you can always fit a straight line through one of the vectors of the surface. The interesting thing is that it seems both a very archaic idea to construct with natural stone, but through thinking of through the development of such new tools, actually exploring these methods becomes quite relevant and interesting. Again, it surely opens up quite a few doors. So in a sense, these manufacturing developing these manufacturing methodology is a design, right? There's an architectural intent and wish motivating the development of these, right? So it's design in a more abstracted, more generalized sense, I think. Now, if you visit Carrara, you see this technology deployed at quite a scale. So this is a 65-ton marble block being processed by such a hot wire. It's kind of fun. So I've been very motivated by this this phrase of Frank Lloyd Wright that I like to refer to. He stated that if I was to realize new buildings, I should have to have new technique. I should have to so design buildings that they would not only be appropriate to materials, but design them so that the machine that would have to make them could make them surpassingly well. And I think that also really speaks to what Alicia was referring about, right? Is that, you know, we're examining what is the potential of these robots, what are the tools that we can develop and really use that to inform the architecture that we are pursuing. So it also takes considerable geometric expertise to overcome some of these limitations, especially in the segmentation of large surfaces to refit these within the kinetic reachability of such industrial robots. And that is taking us to ancient techniques of stereotomy and developing these kind of voussoir geometries. Also, I mean, from a more theoretical perspective, I would say the interest of these robotics is that since the mechanical problem of building is becoming increasingly solved, it's becoming less and less oxymoronic to wish to become a practicing theoretician and a theoretical practitioner, right? And I think at architecture we are always sort of exploring this tension. So that's been interesting. A couple of years ago, we were tendering for this phenomenal bridge designed by Schwarz and Jansma. It's been realized since, where the curvature is has a dominant direction and is slightly curved in the opposing direction. And as a young company with Audico, we're tendering about this, but the hot wire technology that we've developed cannot approximate, you know, the slight curvature in the opposing direction. And as such, we started to develop technology that maybe looks a little crude at first hand, but is actually kind of sophisticated on a mathematical level. We're approximating these geometries through bending a hot blade. So since Audico has IPO'd, I've started to work as CTO at Actual. The thing, what interests me with what we are doing at Actual is that it's a more integrated proposition, right? With during my time at Audico, we're still facilitating building contractors and architects, but where there was not yet a feedback loop of the constraints and the possibilities that these technologies open up, fed into the phase of the design, except for some of the amazing collaborations with SHAJAY and his crew at the AA, which has been formidable. So here I developed a large-scale 3D printing technology, but also a printing platform that allows you to customize these designs online in a bespoke fashion. So with Actual, we're focusing more on fit out rather than pure construction. And here you see one of our printers printing a very large floor, which is one of our first products that has been installed in the airport of Schiphol. And we're constantly expanding our sort of playlist of architectural elements, from floors to facades, staircases, brise-soleil, these kind of elements. So these are the floors that have been installed at quite a few interesting projects. So a couple of years ago, we were invited to revisit the interior for the non-Schengen piers at Schiphol, about 70,000 square meters. The thing though is that in all of these airport spaces, we're clad with, you know, very straightforward 40 by 40 centimeters gray tiles, and whatever you do in terms of interiors, it's just swallowed by an ocean of nondescript flooring tiles. So in a sort of quite from the ground up effort, we developed a new approach to printing floors, which, when you think of it, it opens up 70,000 square meters as an architectural canvas, right? Where we integrate wayfinding patterns in these sort of printed floors. Following, we also utilize this for a couple of beautiful projects at Nike, here in Dubai, in Milan, also at the BMW headquarters. We've developed these floors together with phenomenal architect Patricia Urquiola. So we're also opening up these kind of products we've developed for the input of other designers. We're casting a wide net in that sense. So we're continuing to broaden the list of architectural products that we are developing. And what's incredibly satisfying, for instance, this is just an impression of actually a slightly old film, is that now we employ about 4 or 5 of these robots, but we are printing 24/7, 365. So these machines are crunching through nights, through the weekends, and it's usually we're very it's very exciting at Monday mornings to after the printers at 48 hours to see what has happened over the weekends, and it feels really good to control to work in such a vertically integrated fashion. All right, thanks for your attention.
Thank you so much, Jelle. That was great to see all the work that you've been doing. So next, I'm going to introduce Jason Cameron, who is also going to briefly tell us about his work.
Great.
One moment here, I lost my script. Okay, so Jason Cameron is a program lead of Resilience and Infrastructure Calgary in the Deputy City Manager's Office of the City of Calgary. As the economic lead for Resilience and Infrastructure Calgary, Jason advances an economic recovery built on the success of Calgarians. With Calgary's downtown strategy team, Jason also leads the Connect pillar, ensuring both physical and digital infrastructures, mobility options, and community relationships are in place to effectively connect people, goods, information, and ideas for a resilient and vibrant inner city. Whether it's exploring issues of digital equity, Minecraft students' design challenges, or advancing actions on truth and reconciliation, Jason is at his best connecting big city building ideas with champions of the community, innovators, and his colleagues within the city of Calgary.
Great. I couldn't have said that better myself. So I'm trying to figure out where I fit on this panel, and really I think it is that intersection between these ideas and the actual city building and policy that accompanies it. And I mean, Calgary is a traditional oil and gas city. We're pretty conservative, and we don't like to take risks, which in the volatility and uncertainty that we're all facing can put us in a bit of a disadvantage for sure. So that's one of the reasons, we had a big flood in 2013, and we had started to go into this economic shock in 2015, and we really were fortunate to become part of the Rockefeller Foundation's 100 Resilient Cities Network. They funded us to have a chief resilience officer and then to have a resilient team. And our resilient team, we're the smallest business unit in the city. We're only 7 people, but we do have 4 key pillars that we all work on. We have I lead the future of the city, Calgary's economy, just really that all members of our community are engaged and able to participate. So we look at digital inequity, we look at innovation, we look at the economic inclusion for, again, all Calgarians, whether that's as part of our truth and reconciliation and our Indigenous population becoming playing a bigger role in our economy. But we also look at those inclusive futures, even about how we do democracy. How do we engage equity deserving members of our community? And then again, stemming out of the floods, really understanding the value of our natural infrastructure. How do we monetize it, to be honest, so that we can show that it should be a priority in our budgeting and resources. And then, of course, that we have future-ready infrastructure. We lost a lot of bridges in that flood. We lost a lot of park benches. And so recognizing the value that they have and making sure that our at-risk infrastructure is able to withstand the future shocks and stresses of climate change. So that's Resilient Calgary. That's my big hat. But it allows really what this resilient team does, because we're so small. We're not responsible for getting buses anywhere on time, and we're not responsible for making sure that bridges are built to last or to function. We really are just this capacity within the city to explore what's next. What are those shocks and stressors our city is facing? And how can we apply a future-focused vision on where we want to be? You know, Wayne Gretzky, a great Canadian hockey player, always said, "You go to where the puck. You don't go to where the puck is. You go to where the puck is going to be." And that's kind of what we try to do for our city. But we also have a downtown leadership team, recognizing that our oil and gas transition we are in the midst of it for sure. And we have a glut of empty office space. You know, almost a third of our offices are empty downtown. And we have a ton of offices. We have more empty office space than the city of Vancouver has total, and they're a much larger city than our 1.5 million. So what we've really done is we've partnered with our community, and we've developed 4 main pillars for our economic and downtown recovery. So of course, becoming a great place to live, that great place to work, really focusing on placemaking and vibrancy. And then the pillar that I lead is the connect pillar, where we look to connect people, goods, information, and ideas. So that's the physical infrastructure and digital infrastructure, our 5G and dark fiber, things like that. So, and then really what I'm excited about, I do have some fun projects. So, you know, we have a partnership with IBM and Minecraft, and we've kind of built almost at least a physical digital twin of our downtown for our elementary, junior high, and high school students to play in. And they go and they meet our mayor, and they meet the head of the economic development, and they meet the head of the library, and they talk about the live, work, place, and connecting issues and opportunities in the downtown. And then they're given an empty parking lot and asked to design a block that works for and invites all Calgarians to live, work, play, and connect in our downtown. And then we work with them to celebrate those best designs, and we'll see what that looks like next year when the project is over. And of course, you know, Calgary is big on marketing itself as only being an hour away from the place you want to be in the mountains. So as much as I love the city, we do try to get out as much as possible year round. It's a great place. I'm trying to sell my city here. It's a great place to be, for sure. All right, so if I stop sharing, so really how this fits in with this panel is, can I stop sharing? I think I'm done. Is it, yeah. Am I still up on the screen, or is it done?
No, you're still up on the screen.
Okay. Anyways, there. All right. So, so the city, like I said, is really risk adverse, and so we tend to partner with the university. We partner with civic partners, or we fund organizations that are more able to explore opportunities, especially when it comes to new technologies and things we're uncomfortable with. So We leverage city infrastructure. That's what we have. It's what we're comfortable with to accelerate innovation. So that's whether it's our Living Lab program, where we take underutilized parking lots, dump sites, and we allow post-secondaries, NASA, Lockheed Martin to go and fly drones on city land in the city, which allows them to accelerate the commercialization of ideas. Doesn't cost us anything, but really makes Calgary an easy place to do innovation. Our dark fiber we've got tons of it in the downtown because we're a fairly new city. It's been used to teleport photons, so over 6 kilometers from the university to City Hall. It's even been used to track data, and we've got an autonomous bus test that we use the dark fiber and just the refractions in the fiber to collect data on how many people were on the bus, how fast the bus was moving, and all that data was stored using blockchain and analyzed using blockchain that the city really is too afraid to use. You know, we've got a person in our city that really focuses on exploring blockchain and really so that hopefully one day we'll be where Lithuania was, or Estonia was, 2 years ago, but being able to do voting and doing tax records and 311 calls using blockchain to track that. But we just we're not sure what the public uptake will be, so we're afraid of that, but we're not even there internally yet to use blockchain appropriately. So we do use partners to really explore innovation. And another piece we have with blockchain, we have a group called Calgary Dollars, and we fund them as an organization. What they've created is a digital currency that can be spent at businesses. It can be transferred between individuals. It can be used to pay for social housing, for our own, an internal Craigslist. It can use to pay for bus license or bus passes and your business taxes and things like that. Now it can't be mined, and you have to earn it through sweat equity or a service or something. But yeah, it's great for not just economic development, but really about building relationships and connections, and that it's a participatory piece of community economic development. So relationships, connectivity, that's really where my place is in the city, connecting great ideas with great people. So that's the magic of working in that medium-sized city where, we don't have 6 degrees of separation. You have maybe 2. And that's why I love living in a city of about 1.5 million people, because that person that's dropping off their kid at the same bus stop as you has great city building ideas because she works at the university in the School of Architecture, and she's just built a new friend who owns the pub that's really dog friendly that you love to go to. That's the kind of stuff that happens in Calgary every day. And my job is just to kind of ride along and making sure that I feel like a social convener on a cruise ship. You really should meet this person on deck too. And really, that's I think why I'm here today, is talk about how we connect some of those ideas, how we use those leverage those relationships and that partnership to build trust, to make these kind of innovations in a risk-averse environment.
That's great, thank you. And thanks for that last comment, because indeed I see a great connection also to this particular biennial in Chicago, which is themed around a project that the biennial curator has been doing for a very long time, where he has located over almost 15,000 empty lots in the city, and is trying to activate some brainstorming during this biennial, and also some projects to kind of reactivate those communities and to connect the various pieces and form partnerships with local institutions.
I'd love to talk about that at another time further, because that's a big issue that we've got as well.
Yeah, I mean, most definitely. This is the theme of this year's biennial, and so we'll touch on that today. But I just want to kick off. We do have a question in the question box, and I want to invite everybody to put questions in. And if I want to invite the panelists to turn on your cameras now. And I mean, my intent really, especially with this particular session, is to moderate with a very light touch. I invite all the participants to ask each other questions. It's not just a Q&A coming from me. I'm just gonna kick off by saying, so a couple of things. The first thing is that a lot of times, you know, the desire for a design outcome is what leads us to certain technologies. And certainly because of when I was, you know, in school in the 90s, and we didn't have a lot of the technology that we have right now, neither design nor fabrication technology. We had to sort of invent, you know, manually, and then sort of think forward about the tools that are going to be needed to produce those kinds of things. And then I'm reminded of something that Patrick said in one of the last sessions, that all this technical toil that we go through, you know, both on the design side and on the fabrication side, is really in the service of creating a design experience. And SHAJAY touched on that a little bit in terms of kind of a more societal outlook, where we're kind of breaking up the monotony of, you know, the built experience by engaging users as active participants in the design process, maybe through configurators, maybe through other means. So I guess this is one thing I'm going to ask you guys to touch on. And then I do want to read something from the Q&A box, which is, in the world that you imagine and propose extremely projected towards digitization and automation, how can the problem of lack of work of people not specialized in the use of these digital tools be solved? What is the future of carpenters and simple masons in a world that is proposed? Can automation of processes create, in your opinion, a social problem on the employment of people who cannot afford such specialized education? And I do think Alicia started to touch on that, but I'm going to invite anybody to answer that.
Yeah, I can kind of start to answer that. Like, I think a lot of the work that we have been doing and is really kind of to engage with the community, and it's kind of going back to like the trades and like the workers. And I think that one of the big problems in the UK and when I was there for a very long time was the lack of skilled workers, and the problem was coming from like the lack of enthusiasm to kind of people to actually kind of enter the construction industry. But something is that by driving these tools, there is an opportunity to renew enthusiasm. Like now you have also robots, and you're also working, and you also and the problem is that when you do like manufacturing, construction as manufacturing, the people that are taking those jobs are people that are training in the manufacturing industry. So of course they don't have any skills of like carpentry or like or like masonry or any of the more traditional construction trades, let's say, that are kind of very important and very relevant. The idea of like moving, sending the machines on site is really to kind of, or at least it worked to like engage with them. It created a lot of enthusiasm. Like even people that now has like other skills, so they know how to do carpentry, but now they can also can do like more sophisticated carpentry. And after we built, for example, Nit Candela in Mexico, that was the third shell that we built using concrete in collaboration with ZHACODE. We built 2 other shells before. And one thing that the Masons were saying is like, well, you know what, now we can actually get better jobs because we don't only do slabs that are all the time flat slabs, but now we also have experience in shells on our portfolio. And that for me was something very exciting. And they were like, by the time Nit Candela came, they were really kind of trying to work with us and wanting to work with us. And they were like very willing to like kind of work, like, let's say, like longer shifts. Everything was fully paid, but they were kind of excited. You could see the excitement on the process. So I think that it's really kind of, it's not de-skilling, it's not like kind of automating, but it's more like augmenting them. And in the UK, we did kind of, after we built some of the furniture for like Mobier, which is like an institution that is dealing with the trade, they did launch like kind of advanced methods of construction as a technical kind of program that lasts only like 6 months, where like people can get trained in like kind of just operating the machines. And that's something that we are aiming to, is really aiming towards upskilling. The idea of also of like the micro factory in the island is that eventually they could own it, they could buy it if they get together. It's like not even a quarter of the price of like having the 2 robots doing all the specialized carpentry than like, let's say a Honduras machine, a highly specialized machine to do this. So in terms of economics, it's also something that we are really working to, so that eventually they can get together as a community and keep it for them to keep producing advanced pieces that they wouldn't be doing otherwise. So I think that is a very important question, and the aim is definitely to link back to the community at all times.
So this is a kind of a general question to most of the panelists, and like as architects, I mean, for most of the time since, let's say, the Renaissance, when we started drawing, we've been producing drawings that others have been constructing. And I understand the desire and the logic of wanting to really become a fabricator, because otherwise there's no way to create certain things. But how can we kind of, what's the scalability of, say, the microfactories, or how can this be scaled up so that architects don't necessarily have to become also experts at construction? Or what are the issues that you guys see in that connection, or do you see an issue? Is that even an issue that enters the horizon?
Maybe I can share a view on this question. So in the past years working at ALCIA, there was an interesting following problem. So right, if you want to build something interesting in concrete, the technical challenge is not so much pouring the concrete. I mean, gravity is on your side there. It's mostly developing the formworks, right? So that's, if we express the problem economically, if you go for something for complex geometry, you end up in the range of 60 to 80% of the costs will be in the formwork, not so much the concrete. So what's interesting is that as formwork experts, we were still working, hierarchically speaking, for a building contractor. Now, does that actually make sense if you're if you're doing such a pressing aspect of the work, right? Then you're really starting to realize, maybe I should call the factory the concrete truck the next time, right? If that's but then when you take that idea a bit more serious, there's aspects of liability, etc., right? So you need a certain scale of that, but the economics are interesting, are intricate, for sure. Yeah,
I think one thing I can say, like, I mean, this is not necessarily new, right? Like this, like Yele kind of mentioned Brunelleschi and Alberti, right? That even at that time, like people like Gaudi and others, like they weren't like actually the manufacturers, like, but geometry, they had enough geometric experience to abstract construction parameters into geometric parameters, right? Like, and so while they were designing, they clearly had a vocabulary. They understood the constraints of production. They understood the constraints of structure, as visual and as geometric procedures, right? And so there was an entire construction manual on how to draw ellipses and how to draw domes such that they can actually be cut by cut into stone blocks or cut into carpentry and so on. Whilst the actual carpenters, they had their own manuals, which was taking this level of abstraction to more detail and or less abstract and more real. So I think that ecosystem can be recreated, like through, or even kind of accelerated, and like it can be on steroids in a way through through the means of computation. Like, and if the production is robotic, it also allows for these production processes to be registered in the design phase. So it's not that like architects need to become fabricators or become, they just need to become aware of how to abstract or those parameters and how to take advantage of it, frankly. Like in the bridge that I briefly showed, the texture comes from the way the concrete is laid, like by the printer. And we just took advantage of that fact that it is default coming, that texture is default going to be there. Like it will cost us enormous amounts of money and effort to get rid of that texture. So what we just did was make sure that like the robot traces a path that the outcome is aesthetically pleasing, but also tectonically informative, right? That like it describes the flow of forces through the bridge. And so the idea of, so these ideas of tectonic expression of like structure and of manufacturing have always been around, like, and now it can be like significantly enhanced and made visible with through the means of computational design. And so it's as though like a highly performant design or highly performant shapes and highly performant manufacturing processes afford also a high variety of architectural language affordances to designers. And so yeah, as far as I'm concerned, like we just have to capitalize on these degrees of freedom from a design person. Yeah.
Yeah, I guess looking at this question from the reverse side too. So a lot of technologies have been available for a long time already, but the construction, not the construction process, but the bidding process, putting out drawings for approval. I mean, there's sort of a logic that does not permit, you know, taking your drawing, your BIM drawing, let's say, and just sending it to manufacturer. There's a whole lot of obstacles when you're scaling up. So I was wondering if some of you can address that issue, because it seems like the process of permitting a set of drawings and then sending them to manufacturer lags greatly behind where we are technologically at this point, which is why it seems to me like a lot of these experiments are taking place, you know, on a small scale. But my question is, you know, how can this be scaled up? And actually, Wolf Pricks brought this up yesterday when he was talking about, you know, sort of the construction industry being so incredibly powerful. And, you know, like as architects, it's almost like we don't really stand a chance to kind of break that mold. Except, you know, through means of sort of the kinds of experiments that are eventually maybe going to be scaled up. So I guess that's my question, is scalability and also transformation of the industry.
Yeah, well, maybe Jason can provide a perspective from the side of the city, because one of the reasons like we were excited to meet Jason is exactly this, that like, you know, like we have all these ideas, like, but on the other hand, there is policy and there is, you know, constraints from planning perspective, or as Jason mentioned, like risk aversion, which kind of repeats across like in many countries, right? Like, and so maybe Jason can talk about like what might be the pathway to take these demonstrators and like make the next bigger thing until it, you know, perhaps gets incorporated in
yeah, no, I hear, and to be honest, I really think that my best points on this will be just plagiarized from what you've already told me in our conversations, right? Is that because we're risk adverse and because our building code is so archaic, it's so slow to adapt, right? And we see that, you know, in Calgary with HVAC and new heating methods and things like that, and efficiencies. We, you know, in maker spaces, all that, we say no a lot because we don't know it. And so what you have to end up doing is finding those governments that are desperate, and so that could be in poor countries or countries where money can change policy, or you go to cities like Detroit and now Calgary that are desperate, and so we're doing really cool office conversion, but the city is subsidizing it at $75 a square foot, because changing a footprint from office to residential is not easy. There's tons of regulatory processes. And so we're actually funding it to get that tax base back. And so you need a city that's lost $15 billion in net worth in the property value of their downtown, that they're willing to try anything. And they're putting the last of our money together to do new stuff. That's really cool. So are we ready to, while we can't change federal building code, what you've got is some champions for it, to really push the limits, and also to really advocate for change, or to call everything a pilot. And we're going to try this out and see if this building lasts for 10 years, or if this is still attractive and something the consumer wants in 10 years, and then we'll get rid of the relaxation if it's not. So I think that's fair, right? I think that's what we've kind of talked about before.
So
then that's my answer.
Yeah, I mean, that's really great, and I'm wondering how the gamification of the design, not just the design process, but the whole engagement with the end user, how does that play into these kinds of changes that can be scaled up?
Yeah, maybe like we can touch upon that, and from the perspective of another industry. Like I believe, or at least we believe that, you know, games are like a low entry threshold to deal with much more complicated phenomena and much more complicated issues. And that's where gamification is kind of useful, because it introduces like many of the concepts, like such as economy or economics, in a very simplified format. Like, and so once you cross that threshold, like then you can start doing serious things. Like so, and it also attracts talent, right? Like in this way, because it might be more difficult to attract, like, let's say, computer graphics scientists or economists to look at these new aspects of the built environment, or at least from these new perspectives. But games then provide us like that level of abstraction where you can actually engage with like multiple parties through the design of the game, let's say, like, and which is happening in the crypto game space. Like it's attracting a large number of economists who would have otherwise become central bankers, like now developing like monetary policy and financial policies for games, like and how, what is the transition like to real world effects? Like we don't know, but like there can be this idea of sim to real, that like you kind of work in a kind of SimCity type of sandbox, toy box type of scenario, and like maybe some of that percolates or could become useful when we engage with these pilot projects, whether in a free economic zone, or as Jason said, in a city like Calgary or Detroit. At least that's our hope, that we can engage with these issues, like not shun them away like architects normally tend to do. Like we want to bring them into our discourse, at the same time like be able to engage with the experts. Yeah.
If I can latch on to that, is that Alicia touched upon the fact that young people seem increasingly less interested to participate in building, which I cannot comprehend, honestly, is that especially because in work is polarizing, right? In the sense that the kind of middle ground where you need to do a considerable effort and also are rewarded with an interesting reward is fading, right? I mean, work is polarizing in the sense that you know, an easy task is becoming so easy that anybody could do it, and challenging tasks are becoming that challenging that nobody can achieve it, in a sense, right? You can't make a quantum computer in yourself, right? Anybody can make coffee, but building is fantastic, right? I mean, is that, and what I'm optimistic about also in the perspective of robots is that building has been far removed from self-realization in that sense, right? And I think this also has to do with the fact that building is so demanding physically. So initially we started to work also with foam cutting, because grabbing a cubic meter of foam block, anybody can do it, right? If it's a 40 kilo student or an 80 kilo student, it doesn't matter. You can toss this around, right? No problem. So the fact that, you know, the building has become construction, the act of construction is becoming more of an intellectual challenge rather than a physical challenge, right? Is that the physical challenge is outsourced to the robotic mechanics. So I'm confident that that we will have fantastic builders in the future. I mean, it's just becoming incredibly fun. I think robotics, it's unbelievable, and I think that's also what we are. Maybe SHAJAY and ALICIA can speak to that. It's also what when we work with students in our workshop, is that there's a lot of enthusiasm, right? Because it gives you such agency if you're capable of this, right? And it doesn't take a bodybuilder to build anymore, right? That's an old-fashioned idea. No, so I'm very hopeful.
I think like it was interesting because there was like a conversation 2 days ago with like Virginia and San Francisco, and she was talking about like the robot allowing her to carry bricks she would never carry herself, and now she can like build these domes on herself, right? Which is like so I think that's amazing. But so I kind of share some of the optimism from Jelle, but I think that there is still like a skill. I mean, there is still like a like we as architects, we kind of engage and we want to do these things, but we do still need like kind of the foot soldiers, right? That will actually finish the stuff and kind of, and there's lots of skill on that we are not able to capture yet on the work that we are doing. And that, like, I think that a lot of the processes that we are setting up, there is still like a lot of space where we are like kind of finishing things, where a lot of this is kind of just being done by hand and by people that do have like and maybe because we're working or like right now, for example, this in countries where there is still a skill and these high skilled master builders still kind of exist. So we can rely on them for a lot of the final of the processes, I think. So I do kind of share the enthusiasm into like we are now able to carry and to do things on our own that we couldn't do before. But I do kind of think that we still and we do need to engage with that last step and with like people that will actually finish these things, and that is a skill that we are not able to capture, and I don't know how are we going to capture it in a near future. It's like very much manual skills, and that's where like when you talk about young people not being enthusiastic, it really becomes problematic because then you can only go so far. But there is like a lot of the kind of more complex finishes and things that then suddenly there is no one to do them, and then you end up with things that start to become very generic or not intricate or not complex just because there is no one to do that. And I do think like a lot of the and that is where the problem lies. So it's not into like producing just like the base component. It's actually on not having people coming out and taking this apprentice sort of methodology that we still is very prevalent in all of the trades.
So we have a question here, and the question is, can you share more about your views on architects working with fabricators and new technology stacks?
I think we need more.
Yeah, maybe if I can take that. Like, I mean, at least from like experience at Zaha Hadid Architects, in like as a company, like even from before the time that I joined, like when we are operating in new economies, like when we started building in China, maybe 15 years ago, you know, like we always have to engage with the local supply chain, local processes, and the reason like we are building a lot like in China is because there is engagement from the other side. Like, so fabricators are keen to work with us and change their or expose to us their processes and also change them, and previously also like there was similar at least enthusiasm in the Middle East, and so yeah, we believe like yeah, we bring a certain level of expertise, like in utilizing the kind of degrees of freedom that our architecture language offers. So it is so broadly flexible, like that we can accommodate and actually opportunize on any information that we know about how things are made, how things stand up, and fold it in to the experiences that we want to offer the end users of our buildings, right? Like, and so, and I would assume like other architects like that are operating in this new let's say parametricist or parametric or computational design paradigm will actually want to work with and engage with the fabrication side, because that offers the unique differentiator, right? Like because it's actually beneficial to distinguish the architecture that that architects are producing. And so and on also increasingly, like if sustainable and responsible design is a as is becoming important, like we can only make those gains by revisiting the production process, which has been stable and similar for at least 100 years. Like modernism established that supply chain and that production process, and so that yeah, so if we want to make significant gains, as I try to demonstrate or just indicate through the design of the bridge, like yeah, we have to revisit fabrication, we have to revisit manufacturing, and we have to incorporate those things into our design, which is where we're gonna find the most significant gains, I believe. Like not downstream when everything is already decided. Like you can only gain a few percentage points, but where if you want to make significant changes, like yeah, we have to incorporate and engage with the multiple stakeholders, both on the physical side but also on the policy side and so on. Yeah.
So SHAJAY, you also talked about kind of the technology stack, the existing technologies that can be brought into play together, and sort of, you know, I mean, you mentioned a few things: robotics, video games, 3D design tech, AEC tech, graphic design, and how can those technologies become, how can end users become engaged in the participatory act of contributing in those areas? Like how do configurators work, like in Prospera, the project that you guys talked about?
Yeah, so I think since Jason also mentioned blockchains and Yele's latest entrepreneurial interest relates to blockchains, I think like we should add that to the the kind of the natural progression from participatory design is the next thing is how do you achieve consensus, right? And that's where blockchains are a rich source of both technical literature, but also intellectual discourse. And so the configurators like that we are now testing is a small tip of the iceberg kind of effort, where we want to just showcase that you can actually get people to come together and make choices and negotiate between themselves through some kind of mediation on our part. So that's what we are testing. And so the brief thing that I showed you, like 10 or 11 actual buyers input their choices, and the way we resolved it in that case was just give everybody what they try to maximize everybody's preferences. But we can also have competitive strategies, we can have auctioning strategies, etc. But because the buyers in this case are more friendly, and then they're known to everybody, so we adopted that particular strategy, right, of consensus, where we try to meet everybody's requirements. But they could also be a more aggressive trade-off strategy, dynamic pricing. So I think so the configurators, what it exposes is basically consensus mechanisms, or the opportunity to include consensus, and focus less on the actual aesthetics, or those are more design and expert level decisions, like structure and mechanical devices and so on, which we are now doing as experts after the buyers have kind of negotiated so I think maybe I will open it up like that, to both Yele and Jason, maybe to suggest that the configurator is a stepping stone to a wider consensus mechanism.
Yeah, absolutely. And the thing is that I think, if you extrapolate what has been ongoing in how robotics has evolved over the last 10, 15 years, if you extrapolate, that is going quite well, actually, right? I think what is interesting with opening up users to be involved in design is that, with all these new fabrication techniques, if we don't change how architecture is financed, we're gonna end up with old structures being constructed in perhaps in novel ways through robotics because it makes sense economically. But if you don't change how architecture is financed, not much is going to change. I mean, I have to think of the expression that motor riders use, right? You dress for the crash, you don't dress for the ride, right? And I think that has been exacerbated in how real estate is financed, right? It's not that they wear a leather jacket, it's like medieval full night hood, right? I mean, it's impossible, right? So I think if trust is organized amongst the users, we lack a kind of granularity in contracts, and this is what can be achieved in through blockchain technologies. But it's fundamental in a sense, right? Is that we rebase architecture on a novel kind of contract. I think this is through participatory design we'll get to the next step, and then we'll get.
I mean, just the democratization of data, right? Being able to share as much as you want to get improved service, but being able to control who can see what as well, right? So having my home's information and data, being able for it to be shared across my hydro company, the power company, depending on where you are, and my insurance company, right? So that the kind of shingles I have, the kind of siding I have, is all utilized by the provincial government and their green energy grants, and the insurance company knows that, hey, I've got 35-year shingles, but they're hail resistant, so I get a reduction there. to smartwatch data. We have a smartwatch project with the university that collects how you feel as you move around our city. So as your gait changes on a particular part of our pathway, we can tell that, look, the 100 users on that pathway all change their gait at this point on the pathway. It probably means that a root has uprooted the concrete, or it's an icy patch, or this intersection really causes cyclists' heart to increase. We need to design that location better. But all that data security and that the democratization of that data really depends on a strong blockchain foundation.
There's another element of this, and SHAJAY and I have discussed this a lot, having to do with fractionalized ownership and kind of a more liquid real estate market that is enabled by the blockchain. So there is, this is not something that's as easy to do as making an art NFT, but there are a lot of kind of startups and even like expert real estate people who are transitioning into blockchain and starting to understand like how to install liquidity in real estate and also kind of distribute ownership, either as an investment or maybe somebody goes to it.
I think that's a very important point, and Yele mentioned that like it can actually truly transform the way architecture is funded. It's bringing crowdfunding to like insane scale, right? That and some of these things were actually happening in like mega cities like London, right? Like where London is funding its urban development or regeneration, etc., or gentrification through investors, like at least partially sitting in Singapore or Dubai, etc., right? Like or Russia, and blockchains provides that security and like makes it available to smaller cities. Like for the large part, like many people prefer to invest in London because it's a growing economy, but also the real estate laws are secure, right? Like that, like if you invest, like that you own it, like, or there's a but in other markets like India, like people are afraid to invest in real estate because you don't know whether what you're buying is you have to be on the ground to actually inspect like these properties, etc. And so that's another aspect of blockchains that can bring in investment from outside of the geographic location, and so it could potentially change the way some of the architectural developments or urban developments are funded.
There's a bigger frame question within that has to do with regulatory oversight. Obviously a lot has happened on blockchain, which has been kind of, Ponzi schemes and stuff. So some things have happened that people can point to and say, it's just a risky business, crypto, blockchain, despite the fact that the technology itself is cryptographically sound. So like, what is, maybe a bunch of you can address this, like what is kind of that balance between sort of regulating and sort of allowing entrepreneurship and sort of making sure that people are not getting, screwed, that they're not getting, chipped out of money and they're not losing their investment. So what can you guys say about that balance? Because in a way, it's a little bit like the question of the construction industry versus like the technology that is available already.
Well, I think the liquidity of a house has become an investment in a sense, right? But a house is called what defines is that it's immobile, right? And also as an asset, it's unbelievably illiquid, right? Is that so through fractionalized ownership, you also as an investor, you would never sort of invest all your money into a single company or a property, right? you would spread you would build up a portfolio, right? And so I hope that something like this will happen in the coming decade also in real estate, right? Is that, for instance, now your house, your investment in a sense is also tied to where you live. So if fractionalized ownership could already just break that link, I think it would open many possibilities. And the thing is that I think it's also so difficult to realize interesting architecture is that a priori, before construction happens, before land is purchased, all of the effects, all of the outcome of the project and all of the risks have to be thought of. Its effects need to be thought through and formalized in a contract. So the lack of dynamicism in the contract of such ownership is incredibly problematic, right? So if you would formalize that in a blockchain, you know, a person who pays rent in a certain property can participate in the increase of value of that property, but also the architect initiating the project, service providers, but also building contractors in a sense, right? So if we have more granularity in how ownership is organized, I think we'll have both more interesting projects to build, but that is sort of, I'm not necessarily sympathetic to the idea that your house has become an investment, but it's also a reality, right? The thing though is that if you have access to lots of capital, all of the friction that comes with this ownership is manageable, right? But if your means are more modest in a sense, right? Proportionally, the friction is gargantuous, right? And in that sense, it makes it fundamentally unfair, right? So we live in a world where there's high frequency trading, right? Billions of transactions instantaneously. I mean, anybody who has owned the house is aware of all the friction that comes with house ownership, right? So until we have high frequency trading in terms of square meters, I think architecture will be in a problematic spot, I think.
I think there was a fight. I mean, I think that, yeah, like the problem, and we kind of totally agree on that, in like kind of a house, like still also, I think, is defined in kind of terms that are maybe not accurate for a lot of people anymore. And that kind of brings to the problem of like, to buy a house, what should be inside the house are certain rooms that maybe is not exactly what you need. So that kind of, I think, has like the participatory framework allowing people to kind of say, well, what actually for me a house maybe like, I don't know, I don't need certain rooms, or I don't need kitchens, whatever. That the currently now is the definition of a house is that. I think that also start to really help like these like more granular kind of property, like when you only own some pieces, but that for you in your contract and in your mortgage, in all of your documents, that is your house. So it should be valued as a house. And I think that that's something that definitely needs a redefinition on how contracts are issued and what actually constitutes quarters, or even like all of these dimensions that have been set up for a long time ago, when I think the ways that we used to live were also very different, and even like our societal composition on like the dimensions, rooms, and things that were required. So I think that that's a very interesting thing to be defined with that, through participatory methods, but also to like all the legal and like how can this actually not be made in the city. I was just thinking, like we were talking with, I think Sydney had a program like this in which you could buy like pixels, and that was something that the city was also encouraging people to do, to just buy like 9x9 or something like this. And it was a case study that we were looking time ago in the studio as this idea of like how granular do you go on this distribution, and what is actually the minimum that it's available, or the minimum that constitutes you own something or some part of it.
You touched
yeah.
on some. Sorry, go ahead.
Sure. I mean, for me, I think one of the biggest things we're struggling with in the city right now is if you have money, you have less bureaucratic barriers to doing what you want, so the more you own, the less bureaucracy and policy you have to address. So did that whole discussion about how using blockchain as a part to show ownership and micro ownership, but yet making decisions as a bigger piece would be great. So for me, an example is you can have a 1,200 square foot home. You sell that lot, and the owner of that home could build that lot builds a 4,000 or 5,000 square foot home on that site. And they don't have to go to for us in Calgary, you have to go to council if you want to subdivide that or you want to put in multi-unit residential. So one person owns that whole piece of that whole lot, can build whatever he wants. He can build, they could build a monstrosity on it that doesn't help with our density issues. But if you build something that is more affordable, that offers home ownership and ownership to the masses, then you have to tell your story about why you're putting a basement suite for your mother in your basement. If it was my mother, it's good. We'll stop it there. But I just feel that micro ownership and using blockchain to create a bigger chunk might reduce some of those policies and restrictions that we put on those without means in our city.
Jason, could you comment on fractionalized ownership, where imagine SHAJAY and ALICIA designing an amazing public building, and inhabitants of Calgary being able to invest, let's say, 1 or 2 square meters, in such a building. I mean, as a desperate city, if I'm quoting you, huh?
Well, I mean, we do something like that already, right? But you like our library sold the windows of the we have a beautiful new central library. The windows were all sold, and they sandblasted your name on it, right? And so you were a part of fundraising for that public good. We see that with bricks and stuff all the time. I think again the other piece though would be participatory. If you've bought that piece, do you get to help make decisions around it like you would on a condo board? And going back to the blockchain about being able to democratize so many decisions, from the color of the carpet to your leadership, or how you're going to invest your restricted funds. I think we're doing risk-adverse versions of that now, which really tend to be more about philanthropy. But if it was an office building, or if it was something that could be sold, it was a garden, and that garden could be enjoyed by could be privatized, or find a way to generate money off the admissions. Could we buy 4 meters by 4 meters of a park and then share in the wealth of that of admissions, or the value? If you build a park in the middle of the city, as a group, we all fundraise for it. We build this park, and then it raises the market value of all the surrounding buildings. Do we get a share of that? I think those are some of the kind of discussions we're having now.
It's very interesting.
So I'm just gonna
Just on the
invite
topic, like maybe it was mentioned, but that London has actually it was discussed, like, or mentioned last time, like Vera mentioned it. The London street level democracy attempts to say neighbors can discuss among themselves and raise the zoning heights, and build like another floor. And then the entire street, like if the value of the real estate goes up, like they take a share of, I mean, it benefits everybody, plus there's more place to rent and so on. Like, so maybe starting from these kind of risk averse versions, like maybe you can progressively move upward to more, let's say, more fully participatory mechanisms.
And we do that through levies. We do that through levies now, right? So in a business district, we'll say, okay, every business, you pay $1,500 a year. That'll go to the economic zone, and we'll use that for better streetscaping, murals, shared marketing campaigns to draw people downtown, right, or down to your business district. So we do it a risk-averse way. We show real, attainable, non-risky, non-threat, not new idea, not ground shaking. But yeah, there are ways to do that. Build that collective fund to be spent in that area. I mean, in our business districts, they all have to vote. We have to get 60% of the businesses in that zone to become call it a business improvement area. But it's been successful for us and tons of other cities. I know Seattle's on here too. I think they have that as well.
So we're about 6 minutes from the scheduled time to wrap up, which doesn't mean we have to end right on time, but I just wanted to invite the guests to put in any questions, any additional questions. And meanwhile, if you guys want to say some, kind of summarize what you want to leave us with, that would be great.
I know Greg was asking about mass timber construction, as he's in the Northwest, right? So he's in Seattle, and that's something that they're looking at there. Again, our building codes, I think we just approved 6 stories, and we have nothing like what you have there in Seattle. I can't even remember how tall it is, but it's massive, right? So risk adverse. I think we're as a province, we're coming off 2 massive forest fires that did a lot of damage to downtowns, cities in our province. So fear there. I think we're going to be slow to adopt mass timber multi-level buildings, but I'm really excited again when you bring people like Alicia, when you bring people like Alicia to talk to your designers and your activators of the downtown, they see the potential for timber and design. I think it helps socialize those ideas.
Yella, do you want to leave us with some parting thoughts here?
Well, I'm really excited to hear that these interesting experiments and are taking place in Calgary. But I would wish also for more wider risk averse. This is the part that I don't get. I mean, let's say if you're in such a position in terms of the development of the city, I think risk could also taking risk and exploring these new ideas could also trigger a lot of high potentials, and people you could draw a lot of a new crowd to your city by perhaps exploring this idea of self-realization in architecture, in a sense, right? Is that
being a living lab for sure? Yeah. Come on over.
Yeah, I'm very interested to explore that. Yeah, we would definitely be extremely cool. And I think this almost wedges also into the question that Greg was mentioning, right? Is that I think through these new contracts based on blockchain technology, that it's actually great for ordinary folks to be more involved in development of their surroundings, but also as SMEs in a sense, right? Mostly we're subject to the financial constructs that we're hierarchically involved in, rather than being more proactive with this. So organizing trust is so fundamental if you want to build something exciting. And let's say on a computer science level, this problem has been solved. So I mean, I think there's really a connection here, right? Is that the potential of robotic fabrication hasn't been unlocked, right? Due to lack of granularity in contracting, right? These sort of archaic hierarchies are still there, and it's so this combination, if this short circuitry of formalizing trust on the blockchain regarding a building project and robotic fabrication, I think this will be mind-blowing. So I mean, very exciting to have this conversation.
Thank you so much. I don't know if you guys want to say a couple of words, JJ and Alicia.
Yeah, I mean, maybe I'll go first. And yeah, I mean, like last week, like, you know, we were already excited on like the kind of accelerated experimentation we can do in the virtual, in the cyberspace, like, and we also kind of were I mean, we mentioned that like we as a company, as Zaha Hadid Architects, we're very much like through Patrick's, like, you know, both leadership intellectually, but also like just his enthusiasm, like participating in like the really risk, not risk averse, but like the risk taking endeavors in Liberland or also in Prospera. But like this week, like it's like really good also to know that, like, you know, versions of that like can also be done in a in more risk averse situations. But like, I mean, so that to me is very exciting, also very it increases my optimism that like all these architectural technologies which were kind of just being practiced like by the few, and also like contributing to a few of the high value buildings, can now translate into having like much more mainstream impact, like, which I think like yeah, like it's deeply energizing to know that like it's not only relevant for the high value buildings, societally high value cultural buildings or like urban developments, but like now that it can also start to affect you know, other parts of our built environment, like, and so that's, as an architect, that's like hugely refreshing.
Well, I mean, I think sort of markets traditionally have been seen in a kind of through a romantic lens, right? In a naturalistic sense. It's an 18th century view on this idea, right? It's very Goethean, right? Naturalistic is good in a sense, right? To put it simplistically, but turns out things are much more Darwinian than expected, right? And so in a sense, I think through building on the foundations on blockchain, a new field of design will emerge, market design, right? Because in a naturalistic market, in a sense, right, it's impossible to impose design on it. But if your contract is running live and dynamically and transparently, you can also construct the conditions and the logic throughout which it's acceptable for a market to function, right? And this will shape architecture in an incredible sense. So I'm speculating here, but I think in 10 years, you know, this will be an inherent part of the architecture of a building. In a sense, it's market design.
Yeah, I think it is a very has been a very exciting series of conversations. So also thank you, Daniela, for like putting this together and inviting us. And I think that also like as it has progressed, it's like kind of really seeing that a lot of kind of these ideas on like kind of the participatory kind of decision making, but also the fabrication of these things that are starting to kind of become physical, to really kind of emerge. And I think that yeah, of course, like I think, yeah, like you mentioned, like it's something that has been there and has been like kind of creating a lot of pressure under the surface on all of the robotic fabrications and a lot of these things. But it's like I think like it can really be now like powered, and we see that through like new modes of like what Prospera is doing, or some of the other projects, like kind of new modes of like ownership, new cities, of regulatory frameworks, like blockchain. It really kind of has a lot of can really be out there, and it's a very exciting moment, I think, to be doing this project and to see that ultimately we can actually make it in a bigger scale than the prototypes and than the work that has been developed so far. So I think it's very exciting outlook towards what is going on and to the next few years, definitely.
Fantastic. So thank you, everyone here. Thank you, SHAJAY, wherever you are. For everybody who's here, please join us next week when we're going to have SOM presenting the ZHACODE style set of presentations on their research. So thank you, everyone, and have a good day.
Thank
There's
you.
SHAJAY. Thank you, SHAJAY.
Thanks, everybody. Thank you.
Thank you, everyone.